So this is the review for test number 3. So this example here comes from that book here. It's called Physics, and it's by Johnson and Cutnell. So it's a very good textbook if you want to study biology, or you want to take the MCAT, for example. So this is a very nice example. So they talk about the sport of skeleton. So it's just sled, and you still have like slope to go through, but you see you have to take a turn on a banked track, and it's all made of ice, and it's called skeleton because back then it was done on those sleds here, the old school sleds, looks like a skeleton. Okay. And so this is so here we're going to apply conservation of energy and the energy um, work energy theorem. So you can pause the video, but what matters here, you see the elevation. Okay, it's 126 meters. So elevation, total elevation, is going to be 126 meters. In the absence of non-conservative forces, so that means we neglect friction and we neglect drag, what's the speed at the bottom of the track? Okay, so that's easy because let's say you can say that you have two ways to look at it. You can say, okay, so the work done by gravity on the athlete will go into increasing the kinetic energy. So that's one way to look at it. And it says we suppose that it starts from at the beginning, so initial velocity is 0. So in that case, you can say that the work done by gravity, okay, gravity is a conservative force, so what matters is really the height difference. So even though someone goes from A to B, okay, from here to there, the change in potential energy, which is equals to the work done by gravity, okay, not talking about sign here, so just magnitude will be equals to mgh. So that's going to be h, right? So the work done by gravity will be the change in kinetic energy. So we have mgh equals 0.5 mv squared. And this is very familiar. We always get that when we have no friction, you go from that height to this height, you always have this equation here to find the speed there. And you have V equals the square root of 2gh. Okay? Or you can say that you have conservation of energy. So the potential energy at A plus kinetic energy at A equals potential energy at B plus kinetic energy at B. Okay? And potential energy at A equals mgh plus you start from rest, so there is no kinetic energy, equals to potential energy at B, so you can take potential energy equals to 0 at the bottom, so that will be 0 plus 0.5 mv squared. And you get the same thing, so it's going to be 2 times 10 times 126. If you take g equals 10 meter per second per second. So now what's going to happen? Now you do have friction. And at the bottom, instead of having this speed here, and this speed is 50 meter per second, you have a smaller speed, which means that some of the energy has been lost to heat, because of the work done by friction. Okay, so that means that now you can use you can say, for example, you can use the work energy theorem. So or you can use conservation of energy. You can say that the work done by gravity, okay, so that would be the energy you start with minus the work done by friction, okay, will be equals to the change in kinetic energy. Or you can say potential energy that you begin with, okay, plus kinetic energy that you begin with, okay, minus, okay, minus the energy lost to friction, okay, will be equals to the final potential energy plus the final kinetic energy. Okay, so same thing. Okay, so you're gonna have one problem like this. Okay, so we can say that the potential energy at the top, so mgh minus work done by friction, non-conservative force equals to 0.5 mv squared. So the mass is 118 times 10 times 126 minus the work done by non-conservative forces equals 0.5 times 118, that will be the mass, times the speed is given. Okay? So you can solve for the work done. Okay, so that will be 1118 times 10 times 126 minus 0.5, 118 times 40.5 square. Okay, so you can factor out here whatever. You should get something. Um, you can do the computation. I think you can do it on your own. So it's going to be 118 and then factor out, so 126.10, okay, minus 0.5 times 40.5 square. So it should be 52. Right. 52,000 or 5.2 times 10 to the 4 joules. So here I have two significant values. Here I have three. You can take more if you want. Okay.